Welcome to our deep dive into the serverless generative AI landscape on AWS. Prepare to revolutionize your architecture. If you have ever managed traditional machine learning infrastructure, you know it can be a daunting task. You have to provision instances, manage clusters, handle scaling, and deal with underlying hardware. It takes a massive amount of overhead, time, and resources just to get a model running in production. But Amazon Bedrock completely flips this paradigm on its head. It provides a fully managed, serverless experience that grants you access to industry-leading foundation models via a single, unified API. Think about the profound implications of that for a moment. You do not manage any servers. You do not provision GPU instances for inference unless you specifically require provisioned throughput. You just make an API call, and AWS handles the heavy lifting behind the scenes. How exactly does this fit into the broader AWS AI ecosystem? AWS conceptualizes its generative AI offerings as a robust three-layered stack. The bottom layer is the infrastructure for foundation model training and inference. This includes powerful GPU-powered cloud instances, custom silicon like AWS Trainium and Inferentia chips, and Amazon SageMaker AI, which is a fully managed platform to build, train, and deploy complex ML models at scale. The sheer scale of this infrastructure is absolutely mind-blowing. You have EC2 capacity blocks, elastic fabric adapters for high-performance networking, and hyperscale GPU clusters, all powered by the AWS Nitro system for maximum virtualization efficiency. But as an application developer, you might not want to interact with this bottom layer directly. You want agility and speed. That is exactly where the middle layer, Amazon Bedrock, shines. It abstracts away the infrastructure complexities, allowing you to focus purely on prompt engineering, model customization, and application logic. We are talking about a transformative shift in how we build AI applications. No more infrastructure bottlenecks, just pure innovation. Let us explore how this stack empowers developers to build at unprecedented speeds.
Now that we understand the middle layer of the AWS generative AI stack, let us see how we actually interact with Amazon Bedrock using Python. As a fully managed service, Bedrock eliminates the need to provision any underlying EC2 instances or containers. You interact with it entirely through serverless API calls. But how do we know which foundation models are available to us? We can use the List Foundation Models API operation on the control plane. Amazon Bedrock separates its APIs into a control plane for management tasks and a runtime plane for inference. The control plane allows us to list models, view model details, and create customization jobs. By utilizing the AWS SDK for Python, known as Bodo3, we can seamlessly authenticate and query this control plane. It is incredibly straightforward. You do not need complex networking or cluster endpoints. You just specify the service name and your AWS region. Let us dive into the code and see exactly how we can retrieve a complete catalog of foundation models dynamically. Let's look at exactly how this code works to interact with the serverless API. We begin by importing the standard Bodo3 library, which is the AWS SDK for Python. We then initialize a client for the Bedrock control plane by specifying Bedrock as our service name and US East 1 as our target region. Notice that we are not specifying any IP addresses, clusters, or load balancers. The serverless nature of Amazon Bedrock abstracts all of those infrastructure concerns away from the developer. What happens when we call List Foundation Models? Having explored the bottom and middle layers, we finally reach the top layer of the AWS generative AI stack, applications that leverage large language models and other foundation models. While Amazon Bedrock provides the tools to build your own custom solutions, AWS also offers pre-built, fully managed applications that utilize generative AI under the hood. This layer is designed for organizations that want to realize the benefits of generative AI immediately, without investing development cycles into building from scratch. What is the flagship offering at this top layer? It is Amazon Q. Amazon Q is a highly secure, generative AI-powered assistant designed specifically for business and developer productivity. What makes Amazon Q so powerful is that it comes in tailored flavors. For instance, Amazon Q Business connects securely to over 40 popular enterprise data repositories using native connectors. It acts as an intelligent assistant that can answer questions, summarize documents, and generate content based strictly on your company's proprietary data. It respects your existing IAM permissions and access controls, ensuring that users only see insights derived from data they are authorized to view. Then you have Amazon Q Developer, which sits directly inside your integrated development environment. It accelerates software engineering by offering real-time code suggestions, generating tests, debugging complex errors, and even automating legacy code upgrades. These top-layer applications abstract the entire generative AI pipeline. You do not need to worry about prompt engineering, vector databases, or model scaling. AWS handles all the complexity of the underlying Bedrock infrastructure, allowing your business users and software engineers to experience massive productivity gains from day one. This complete three-layered stack ensures that AWS has a solution for every persona, from infrastructure engineers to everyday business users. This diagram shows how Amazon Q serves as the ultimate interface, securely bridging the user's queries with back-end enterprise data repositories and underlying Bedrock inference engines seamlessly. One of the most compelling aspects of Amazon Bedrock is how seamlessly it integrates with the rest of the AWS serverless ecosystem. Because Bedrock exposes its foundation models through standard RESTful APIs, you can easily invoke these models from AWS Lambda functions. This allows you to build completely serverless, event-driven generative AI applications without provisioning a single virtual machine. Why is this architectural pattern so valuable? Imagine building a customer service chatbot. You can expose an HTTP endpoint using Amazon API Gateway, which triggers an AWS Lambda function. The Lambda function processes the user's input, structures the prompt, and securely invokes an Amazon Bedrock model. The model generates a response, and Lambda returns it to the user in real time. This entire pipeline scales elastically from 0 to thousands of concurrent requests, and you only pay for the exact compute time and tokens you consume. Let us examine a practical code example of an AWS Lambda handler designed to invoke an Amazon Titan text model via Bedrock. Let's dive into this AWS Lambda function to see how effortless serverless AI integration truly is. We define the standard Lambda handler entry point, which receives the event and context objects. Inside the handler, we initialize a Bedrock runtime client using the Bodo3 library. Notice that we specify the Bedrock runtime service, which is strictly utilized for inference and model invocation operations. We extract the user's prompt directly from the incoming event payload. Next, we construct a JSON payload formatted specifically for the Amazon Titan text model, passing our prompt into the input text field. Now for the magic.
When discussing serverless generative AI on AWS, we must address the most critical priority for any enterprise: security and privacy. A common hesitation organizations have when adopting large language models is the fear that their sensitive, proprietary data might be absorbed into public training datasets. This is a massive compliance and intellectual property risk. However, Amazon Bedrock eliminates this concern entirely through its secure, tenant-isolated architecture. First and foremost, AWS unequivocally guarantees that your prompts, your completions, and your fine-tuning datasets are never used to train the base foundation models. Your data is never shared with third-party model providers like Anthropic or Meta. How does AWS enforce this? When you invoke a model, the data processing occurs entirely within an isolated compute environment in the specific AWS region you select. Your data remains strictly under your control. Furthermore,
All data is encrypted in transit using TLS 1.2 or higher, and encrypted at rest using AWS Key Management Service, or KMS. You can even bring your own customer-managed KMS keys for ultimate control. Amazed. For network security, Bedrock fully supports AWS Private Link. This allows you to establish a secure, private connection between your virtual private cloud and the Bedrock service. Your inference requests never traverse the public internet. They stay securely routed within the AWS global network backbone. Excited. Finally, access is governed strictly by AWS Identity and Access Management. You can craft granular IAM policies to ensure the principle of least privilege, restricting exactly who can invoke specific models or access training data. With Amazon Bedrock, you are getting a serverless AI environment that is compliant with GDPR, HIPAA, and SOC standards right out of the box. This enterprise-grade security posture empowers organizations to innovate with absolute confidence. This architecture guarantees privacy. The customer VPC routes traffic through AWS Private Link directly into Bedrock, completely bypassing the public internet, while KMS rigorously encrypts the artifacts at rest.
As we continue our exploration of the serverless AI landscape, we must discuss how operational paradigms are shifting. Traditionally, we relied on MLOps, machine learning operations, to manage the lifecycle of models. MLOps provided robust frameworks for data collection, model training, validation, and deployment. However, generative AI introduces entirely new complexities that traditional MLOps simply was not built to handle. Why is that? Foundation models are massive. You rarely train them from scratch. Instead, you interact with them via prompts, you connect them to knowledge bases for retrieval-augmented generation, and you fine-tune them using parameter-efficient techniques. This paradigm shift has birthed Gen AIOps. Gen AIOps is a specialized extension of MLOps tailored specifically for the unique lifecycle of large language and foundation models. In a serverless environment like Amazon Bedrock, Gen AIOps focuses heavily on prompt engineering and prompt management. You need version control for your prompts, continuous evaluation of model responses for toxicity and hallucinations, and sophisticated routing mechanisms to select the right model for the right task. It is a completely different ballgame. Gen AIOps also encompasses FMOps, which is foundation model operations, dealing with the deployment, cost optimization, and scalability of these massive models. With Bedrock, a huge portion of FMOps is abstracted away because AWS handles the infrastructure. You do not need to worry about GPU provisioning or cluster health. Instead, your Gen AIOps pipelines can focus on application-level metrics, tracking token usage, monitoring user satisfaction, and seamlessly updating your RAG vector databases. It is a streamlined, highly agile approach to operationalizing AI. By embracing Gen AIOps, your teams can deploy serverless generative AI solutions that are resilient, scalable, and continuously improving over time. This illustrates the operational evolution. Traditional MLOps branches into Gen AIOps, focusing intensely on rigorous prompt management and abstracting infrastructure burdens through Bedrock's serverless FMOps. Before we wrap up this module on the serverless AI landscape, we must acknowledge the challenges and strategic considerations involved in deploying these architectures at an enterprise scale. While Amazon Bedrock drastically simplifies the deployment of foundation models, building production-ready generative AI is not without its hurdles. One of the primary challenges is managing prompt complexity and context windows. Even though serverless APIs can handle massive payloads, feeding an enormous document into an LLM can lead to high latency and exorbitant token costs. How do we mitigate this? This is where advanced architectural patterns like retrieval-augmented generation, or RAG, become absolutely essential. By integrating a vector database and extracting only the most relevant text chunks, you optimize both performance and cost. Another significant consideration is model observability. In a serverless paradigm, the underlying model is essentially a black box.
You must implement robust monitoring using Amazon CloudWatch to track invocation latency, input token counts, and output token counts. Understanding these metrics is vital for maintaining a responsive and cost-effective application. You also need to continuously evaluate model outputs for accuracy and fairness, utilizing human-in-the-loop workflows to ensure that the generative AI aligns with your corporate guidelines and brand voice. Embracing these best practices will ensure your serverless AI initiatives are wildly successful. I hope this deep dive into the AWS generative AI landscape has been enlightening. We invite you to like this video, subscribe to our channel, and visit quicktechie.com for premium, recently updated material as per the latest syllabus and certification prep, including Q&A banks, ebooks, audiobooks, full training, and interview guides. Mitigating challenges is systematic. We resolve token bloat via RAG, overcome the black box nature using CloudWatch observability, and guarantee accuracy through targeted human-in-the-loop evaluations.